Practice test for solutions. Number one, what two components or parts do all solutions by definition contain? That would be the solute and the solvent. The solute is the stuff being dissolved, and the solvent is the stuff doing the dissolving. Most of the time, the solvent would be water. Number two, which of the following best defines a solution? Well, that would be a homogeneous mixture. Now, besides color, a homogeneous mixture, you really can't tell there's anything dissolved in the solution at all. Which solution is more concentrated? 2 moles dissolved in 1 liter or 1 mole dissolved in 1 liter? Well, of course, 2 moles dissolved in 1 liter is going to give you a 2 molar solution, which will be more concentrated than a 1 molar solution. The units for molarity are expressed in moles per liter. Moles per liter, also called molar or molar concentration. Which solution in the picture is most concentrated? Well, the darker the color, the more concentrated it is. Number 7. Which solution in the picture to the right is more a dilute? Now, the blue dots are the solute particles, and the pink dots or purple dots are the solvent. So if we have a lot of solute compared to solvent, that would be concentrated. So the least or the dilute one then would be the one on the left. Number 8, which solution contains the most solute? Now, dissolved fat, that would be your solute in milk. So we got 1%, and 2% would be more concentrated. Half and half is half cream, half milk, and that's usually about 10 to 12% milk fat. And skim milk is the lowest. Number 9, like dissolves like is a very general rule used for predicting whether a substance will form a solution with another substance. Now, like is a lot to do with polarity. So if molecules contain a plus and a minus N to them, they would be polar. So two kinds of substances like that will dissolve into each other. Number 10, describe and draw the process of solute dissolving in a solvent. Now, first we might think of water molecules. You only got H2O, and the water molecule has a plus and a minus end to it. So if we have a ionic substance like sodium chloride, it's going to break apart into sodium ions and chloride ions, minus. And the water molecules with their negative end will surround the sodium ion, and the water molecules will surround the negative chloride ion with their positive end toward the chloride ion. Number 11, define saturated and unsaturated. Saturated means that you have the maximum amount of solute dissolved in the solution. Unsaturated means you'll have less than the maximum amount of solute in the solution. Number 12, at room temperature, the solubility of salt in water is 17 grams per 100 grams of water. All right, now by solubility, what we mean is that's the maximum amount of salt that can be dissolved in that much water. A scientist prepares the following solutions. Identify them as being saturated or unsaturated. Now, the first one has 10 grams per 100, and the max is 17. That would put that as unsaturated. And if we have exactly 17 grams in 100, that's our max, so that is our saturated. we were to get more than 17 in there, we would call it super saturated. We'd probably have to heat it up to make that happen. Number 13, how does the solubility of a solid, how much dissolves, change when temperature is increased? Well, let's say generally solubility will increase with temperature. But if we look at the graph below here, if the graph is sloping up for these compounds, then the solubility increases with an increase in temperature. But there are a few on the graph that go the other way. So as the temperature increases, less will dissolve. But most often, heating will increase the amount that you can dissolve. All right, identify 3 ways you can increase the rate in which a solute will dissolve. You could crush or pulverize or powderize the solute. It will dissolve faster. You could shake the mixture, and that helps dissolve it faster. Or in some cases, you could heat it, and it will dissolve faster as well. Number 15, using the graph shown below, which substance has the smallest change in solubility from 50 to 100? Well, that would be the graph that rises the least amount as you go from left to right, and that looks like the line labeled sodium chloride, NaCl. It rises the least amount when you go from left to right, increasing temperature. To make a saturated solution, how many grams of KNO3 can be dissolved at 40 degrees? All right, KNO3, that is this line right here that slopes up at 40 degrees. At 40 degrees, we'll go up to the line, and it looks to be right around 60 grams of KNO3 at 40 degrees. That would be into 100 grams of water. Number 17, which substance is saturated at 90 degrees with 70 grams in 100 grams of water? All right, let's take a look at that. Let's see, at 90 degrees, 70, there's 70 right there. 70 grams in 100, that would be NaNH4Cl. That's ammonium chloride. If you add a bunch of sugar to a cup of coffee, you'll find that some of it will be remaining at the bottom of the cup no matter how much you stir. Explain why no more dissolves at that point. All right, you would have a saturated solution of sugar, and adding any more, then you can't dissolve anymore. It's already saturated. So adding more will just sink to the bottom and sit on the bottom of the cup. A saturated solution. Number 19, making dilute solutions. You start with concentrated solution known as a stock solution. Now in the lab that we did, the crystal violet was our stock solution, and then we diluted it by adding water to it. Number 20, what is an electrolyte? That would be a solution containing ions, positive and negative ions. It is also a solution that conducts electricity. All right, in the lab, we put that electrode in there, and it measured how well it conducted electricity. So an electrolyte, a solution containing ions that conducts electricity. Okay, here we have some calculations. These formulas will be right on the test, pretty much just as you see them right here. That is your cheat sheet. All right, let's look at number 1. Calculate the percent volume of a solution that has 14 milliliters orange juice and 97 milliliters of water. The percent by volume would be this equation, and they give us the milliliters of solute, which is 14 milliliters of juice, divided by the milliliters of a solution, which we have to add both of those together. 14 plus 97 gives us 111 milliliters of solution. Times 100 will give us a percent. That would be 13%. 13%. Number 2. Calculate the number of moles in 1.5 liter sample of a 2.2 m solution. Now, m means molar or moles per liter. So we are looking at the first equation here. M is the molarity, and we want to solve this for the number of moles. So if we take this equation and do a little bit of algebra, we will have the number of moles of solute equal to the molarity multiplied times the liters of solution. Now they tell us the molarity is 2.2 moles per liter times the volume of 1.5 liters gives us 3.3 moles. Number 3, hand sanitizer contains 85% ethanol in 750 milliliters. All right, so we got a volume and a percent, so we are probably talking about percent by volume. Now, we want to know how many liters of ethanol there are. So ethanol is the solute. So if we take that equation and solve it for milliliters of solute, we are going to get the percent multiplied times the milliliters of solution. And the percent they tell us is 85.0, and the milliliters of solution 750. Now remember, when you punch in a percent, you punch in 0.85. So 0.85 times 750 is 638 milliliters. Number 4, how many moles or how many grams of Hg, that's mercury, are in 4.35 parts per million solution that contains 15,005 grams of solution? All right, now we're ppm, parts per million. So we are looking at this equation, parts per million, and we are given the ppm, we are giving the grams of solution. So what we have to find here are the grams of solute. All right, doing a little bit of algebra then. Grams of solute. This could be a little tricky here. The grams of solute is going to be equal to the parts per million multiplied times the grams of solution, and the whole thing then divided by 1,000,000, 6 zeros. That's doing algebra, solving for the grams of solute, which in this case is mercury. All right, our numbers: 4.35 parts per million, grams of solution 16005 divided by 1,000,000, 6 zeros, gives us 0.0696. Now that's going to be grams of solute, in this case mercury, Hg, 0.0696. Okay, number 5. A student combines 1.75 grams of sucrose with 12.5 grams of sodium chloride and 1,245 grams of water. All right, what's the percent by mass of sucrose? So percent by mass. All right, we are looking at the percent by mass equation here, and the grams of solute in this case is going to be sucrose, and the grams of the solution now is going to be all of it added together. All of it added together. All right, so the percent by mass is going to be the grams of solute, in this case the sucrose, which is the 1.75, divided by the whole. We'll add those all together. That gives me 1,259.25 grams of solution. Right now, times 100 will get us our percentage. So 1.75 divided by 1,259.25 times 100 gives us 0.139. So 0.139%. All right, 1.75 out of 1,000 is a very small percentage. What's the percent by mass of the NaCl? So then we will have the grams of NaCl, 12.5, also divided by the total, 1,259.25. Take that times 100 and we'll get our percent equals 0.993. 0.993%. So 12 is still a very small percentage of the whole, which is 1,059.25. Number 6, calculate the milligrams, mg, of aspirin in 140 grams if it's 1.5 parts per million. So we're looking at our parts per million equation, and I want to find the milligrams of aspirin in 140 grams. All right, now the 140 grams is the grams of solution. So we have our parts per million, and we have our grams of solution. We're trying to find the grams of solute. So if I do a little algebra and solve that, I'm going to get my parts per million multiplied times my grams of solution divided by a million is going to equal the grams of solute. All right, parts per million, they tell us is 2.5. The grams of solution, they tell us is 140.0 divided by 1 million. Oops, I forgot a few zeros over here. All right, and that equals 3.5. Now my calculator says 3.5 e minus 4. All right, I could leave it as that, or I can write that as 0.00035, and that's going to be grams of aspirin. Now, notice what they asked for, though. They want the milligrams. So if that's the grams, how many milligrams is that? I'd move the decimal 3 to the right. That's going to be 0.35 milligrams. That would be the answer that they're looking for. 0.35 milligrams. All right, number 7. Calculate the grams of solution needed to get 5 grams of sugar from a 10% by mass solution. All right, 10% by mass. So what equation are we looking at here? Percent by mass. Percent by mass. And they give us grams of sugar. That's here, grams of solute. They give us the percent, and we want to find the grams of solution. So if we solve this equation for grams of solution doing some algebra, all right, we will get grams of solution equals grams of solute divided by the percent mass times 100. All right, doing a little bit of algebra. So grams of the solute is 5. The percent by mass is 10, and we want to, well, we'll put that in as 10%. Remember, we're going to type it in as point, and then times 100 gives us
50 grams of solution.
Number 8. How many moles of C12H22O12 are present in 5 milliliters, that's a volume, of 0.75 molar, that's the molar concentration, capital M, and we're trying to find out moles. All right, we are looking at using the molar of solution. All right. Now, if I solve that equation for moles, then the moles of solute is going to equal the molarity M multiplied times the liters of solution. And they tell us the molarity of the solution is 0.75 moles per liter. And the liters of the solution is 5.0. So we will end up in moles. 0.75 times 5 gives us 3.75. 3.75 moles of the solute, the C12H22O12. Number 9. If a student places 28.75 milliliters of grape juice into 495 milliliters of water, what's the percent by volume? Percent by volume. We are looking at the percent by volume equation, and they tell us the milliliters of grape juice and milliliters of water that are mixed together. So the milliliters of the solution is going to be those two added together. What is the percent by volume? Percent by volume then is going to be the milliliters of the solute, which is the grape juice, 28.75 milliliters, divided by the milliliters of solution. That would be those two added together. That would give us 523.75. That's the milliliters of solution. And it's times 100 to make it into a percent. So we will get 5.489. 5.489% by volume. Number 10, how many grams of NaCl are there in 356 milliliters of a 8.7 molar solution? All right, now, this one is at a couple of steps because we are looking at the molar equation, and we want to know how many grams, but we could find out how many moles of NaCl there are. Taking that equation, solving it for moles of solute would be equal to the molarity M multiplied times the liters of solution. And they tell us that it's 8.7 molar times the liters of a solution. Now, given milliliters, we want 0.356 liters. And this is going to give us 3.1 moles. Now, they're asking for grams. So we got to have an additional step of multiplying that times the molar mass. All right, the molar mass, which we would get from the periodic table. So for 1 mole of NaCl, how many grams? So we'll look up sodium, 22.99, plus chlorine, 35.45. So that molar mass is 58.44. 58.44 times 3.1 gives us 181.16 grams of NaCl. All right, we have one last problem. Beer's law, that relates to the lab that we just did at the end. And we have a graph. Question 1, how is absorbance and concentration related? So if we look at the graph, the concentration goes up and the absorbance goes up. So they are directly related. When one goes up, the other one goes up in a linear fashion. Number 2, interpret the graph. What is the concentration of a sample with an absorbance of 0.56? You must use the equation of the trend line. Show your work. Now, we have the equation right there. And Y is the absorbance. All right, ABS for absorbance. Y equals mx plus b. M is 14340 times x. X now is the concentration plus b, 0.0215. So that's our equation. And the absorbance, they tell us, is 0.56. So that's going to go in right here. We have to solve this equation for C. Algebra, what would that look like? I will get absorbance minus 0.0215. The whole thing divided by 14340 is equal to C, the concentration. So we'll put in the absorbance they give us, 0.56. That minus 0.0215 divided by 14340 equals
3.8 times 10 to the minus 5, or 0.00038 molar. That's our concentration. Now, we had to use the formula because that particular point is off of the graph. All right, 0.56 is way up here somewhere, completely off of the graph, and we had to get a number that was off of our graph. But no problem when we're using the formula. We're extrapolating past our data. All right, thanks for watching.